Okay, so I want to explain heat capacity, specific heat, and specific heat capacity. And I know you've heard these words before. You have also seen this formula, MC delta T, right? Do you know where it comes from? MCAT?
Yes,
True, but let's try to develop this. This is actually really fun to understand. Heat capacity. And specific heat. Okay, how do we change the temperature of a system? Question mark. There's only one way. Temperature is related to only one property of the system. When energy is put in, the temperature goes. When energy is taken out, the temperature goes. Right? So when you put in energy, the temperature of the system goes up. When you take away energy, the temperature of the system goes down. Now, how do you do that? We know from our first law that temperature is this part of that equation, right? So how do I change the temperature of anything? I can do it by adding heat to it, or which I will call compressional work, right? So I can either do work on the system by compressing it, decreasing the volume. All of those make sense. I'm just trying to get you to think of them in the right terminology, right? And how do you decrease the temperature? By taking energy away, right? How do you do that? By either taking away expansion, right? One, you could expand it, which in thermodynamics, it will be called work done by the system. Starting again, how do you decrease the temperature of a system? We're going to write this down. Don't write this down. Just pay attention. Okay, starting at the beginning. How do you increase the temperature of a system? By either, what can you do? There's two things you can do. You're increasing the temperature. How will you do that? By adding heat to it, or by
pressure.
Compression, right? Which basically means is you're adding pressure to it. So you're doing work on the gas. Get it? Number two, how do you take away energy, or how do you take away temperature? Well, how do you decrease the temperature? By taking away the energy. How do you do that? One would be, start from heat. The Q comes first. So you could take away heat. Think of Sami's story, right? He could throw things in or out of the windows. So from window Q, he could either throw it out or he could pull it back in. And number two, what else can he do? Or else what we can do with W? What is that called? Expansion work. And how do thermodynamics call it? Work done by the gas. Okay, now let's write this down. This is very important. Once this becomes clear to you, half your thermodynamical problems are solved. This is one of the most difficult things to understand because we all call it like slightly differently, work done by the gas and on the gas. I kind of think of them in these terms and I never go wrong. Okay, so how do we start? How do we increase temperature? By increasing delta U in our equation, which we can do by adding heat or by doing work on the gas. which we also called the compressional work. How do we decrease T? By decreasing, oh my God, my handwriting.
Mine's bad too, Dr. C, don't worry.
Or negative work, which is also called work by the gas. And that is called, Gwen said it, what was it? Expansion.